David Smith here with yet one more Flipped Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit you. You can also pause a video at any point and jot down notes or write down questions for our next class. Lastly, you can turn on the captions and read my words on the screen. Today's topic covers general term formulas for geometric sequences. And we're going to do a bunch of tips and tricks where we can find the number of terms, we can find R, and we can find the value of specific terms in geometric sequences. Now let's take a look at general term formula for geometric sequences. Here we have UN is U1 times the common ratio to the n minus 1 power. So remember, nth term, first term, common ratio. So like D is essential to understand for an arithmetic sequence, R is essential to understand for a geometric sequence. Okay, with geometric sequences, we have 2 categories that are kind of interesting. So if the common ratio is bigger than 1 or less than -1, then the sequence is considered divergent. And what that means is that, let's take a look at bigger than 1, the sequence is just going to keep growing. R is 1, so it means it's, or bigger than 1, so each term is going to be bigger and bigger and bigger by an increasing amount because this exponent is going to get bigger and bigger and bigger. So the sequence is divergent. You can't create a sum for this because depending on how many terms you calculate in your sum, it's going to keep on growing. Now, if R is between -1 and 1, like a fraction, like 1/2, then the sequence is considered convergent, which means that the terms are going to get smaller and smaller and smaller and smaller, and it's going to converge on a number. And that means that you can find a sum for a convergent sequence. We're going to sum these later. Today we're just going to use the general term formula, but you need to understand these 2 concepts. Okay, here's a typical type of problem you might get with a geometric sequence. Here's our sequence, 40, 20, 10, ... to U12. So the prompt here is find R and U12. Now R is pretty easy to figure out on inspection. We just multiply the previous term times 1/2 to get the next term again and again and again. So I can just simply write here R is 1/2. Now I want you to pause the video and do a plug-in step for this formula to find U12. All right, so here's my plug-in step. U1 times 1/2, that's our R, to the n minus 1. We're looking for the 12th term, so we do to 12 minus 1 power, or 11th power. What I do is so you can just pump this into your calculator and go straight to the decimal. That's fine. You can also play with fractions, which I like to do. It keeps me sharp. So 1/2 to the 11th power is 1 over 2048. When you multiply that through by 40 and reduce, you get 5 over 256. All right, so here's another sequence. 1/2 minus 1/4, 1/8, and so on, all the way up to U9. So now they're going to ask us to find R, again, like we did last time, and find U9. Okay, I want to give you an easy way to find your R. Sometimes it might not be quite so obvious from your sequence. This one I think you could probably just get by looking at it, but sometimes that's not the case. So the trick is you can take any term, like n, whatever term that is, 3rd term, 4th term, 20th term, and divide it by the term before that, and that will always give you your n. So watch this. I'm going to go with minus 1/4 divided by 1/2, and that's going to give us minus 1/2. And you can see from the sequence that we're just multiplying each term by -1/2 to get the next term. So that gives me my R. So now I want you to find the 9th term in this sequence, plug in and do your math. Let's see how you did. So check this out. Here's my plug-in. U9 is just 1/2 times -1/2 to the 9 minus 1 power. So let's evaluate that. The 9 minus 1 power is the 8th power. Whenever you raise a negative number to an even power, your result is positive. So I have U9 is 1/2, there's my first term, times 1 over 256. So 1/2 times 1 over 256 is 1 over 512. Perfectly good answer. If you want to decimalize it, it is 0.00391. Okay, Let's do this one. I'm just going to stop it right here. We got 87, 8.7, 0.87, all the way to U6. The prompt, find U6, pause the video, and do that. Okay, here we go. R is 0.1. You can see that. We're just multiplying each term by 0.1 or 1/10. Okay, so check this out. Our plug-in step is U6 is U1, 87, times 0.1 to the 6 minus 1, or the 5th power. Crunch those numbers, you get U6 equals 0.00087. One last problem. Here we go. Here's our sequence, a little bit more abstract. 7x, 14x squared, 28x to the third, and we're going to need to find U8. So pause the video, think real hard. What is R in this case? What are we multiplying each term by to get the next one? And once you've determined R, use our general term formula and find U8. All right, so first off, finding my R. So I just divided this term by that term. 14x squared divided by 7x gives me 2x. That's what I'm multiplying each term by to get the next term. Then I did my plug-in step. U8 is going to be the first term, which is 7x, times our common ratio, 2x, to the 8 minus 1 power. That 2x to the 7th power gives us 128x to the 7th. Multiply that by our first term, and we get 896x to the 8th power. Okay, let's do another example using the geometric sequence formula. So I've put your formula up there, and here's our problem. We know that U1 is 81, and then we're skipping a bunch of terms, and we know that U6 is 1 over 729. So this is definitely going to have some fractions going on here. And here's our prompt. We're being asked to find U2, 3, 4, 5 such that the sequence is geometric. So this is just sort of fancy math for saying, here's a geometric sequence, we're missing 4 terms, find them. So your first trick, you gotta find R. We know U1, but we just don't know R. So pause the video and think about that for a minute. See if you can come up with a way to find R. All right, so we do have enough information. We just do a plug-in step with our formula. We know U1 is 81, and we know U6 is 1 over 729. So this number, 1 over 729, is going to equal 81 times R to the 6 minus 1, which is 81 times R to the 5th. Now we can solve that. You're going to have to remember how to take a 5th root. Now try to do that on your calculator and come back. All right, so the first thing I did is I divided my 81 away from my R to the 5th. Dividing 1 over 729 by 81 gives us 1 over 5949, and that's R to the 5th. So in order to get R by itself without the 5th, we take the 5th root of R, and so that leaves us with R on this side. Then we're taking the 5th root of this big fraction, 5th root of our fraction, and that works out to just be 1 over 9. So now we have our R. Now we can answer this question. What is U2, 3, 4, and 5? So go ahead, pause the video. You have the general term formula. You know R now. You know U1, so you can find U2, 3, 4, and 5. All right, so here's what I get for U2, 3, 4, and 5. I get 9, 1, 1/9, and 1/81. Now take a look at what's happening. We're just doing repeated multiplication by 1/9, which is the same as repeated division by 9. And it makes sense. To get U2, I'm just dividing U1 by 9. I get 9 because there's 9 9s in 81. To get U3, I divide U2 by 9, which gives me 1, and so on to 1/9, 1/81. If I divide this by 9, or multiply the bottom by 9, I'm going to get 1 over 729 for U6. Let's do another one for another geometric sequence. We're going to use our formula here. Now here's our givens. We've got 5 for U1, U5 is 1280, and our last term is 20,480. And then they're also giving us that R is greater than 0, which means R is positive, okay? So here's the prompt. We need to find N. How many terms are there in this sequence? We know the last term, so we should be able to describe this sequence, come up with its formula, find R, and find how many terms there are. So what do you think the first step might be? Let's find R. And we can do that in a similar way as we found the last time because we know U1 and we know U5. So pause the video and do that plug-in step that will allow you to solve for r. All right, so what I did is I just plugged in my u5 here, and I know I can get u5 by multiplying u1 from here by r to the 5 minus 1, or 5 times r to the 4th. Now go ahead, pause the video, and let's solve this for r. Okay, dividing through by 5, I get 256 equals r to the 4th. Take the 4th root of both sides, I get r equals plus or minus 4. Now we have an even root, so we do have a negative solution to that. However, we've been told here that r has to be positive, so we get rid of the minus, so r here is 4. So now, let's go ahead and solve for n. All right, I changed my situation here where it said r is greater than 0. Now we know what r is, so I just changed that to r equals 4. Now go ahead and do a plug-in step that's going to allow you to solve for n. Okay, here's my plug-in step. Here's my last term. And the way we find the last term, the way we calculate it, is by multiplying the first term times our r to the n minus 1. And the n is what we're solving for at this point. So go ahead now and pause the video and let's see if you can work that all the way through to find n. All right, so my first step here is to divide through by 5. I get 4,096 equals 4 to the n minus 1. Now, unlike the last problem where I could take a root, I can't take the n minus 1 root of 4,096. There's a variable in there, so I can't do that. But if you remember your logs, you'll recognize that this is a log type equation. I have 4 raised to some power equals 4096. So I can rewrite that as a log as log base 4 of 4096 equals n minus 1. Now if I put this into my calculator as a base 4 log, I'm going to get 6 for that. So 6 is n minus 1, so that means n is 7. Now I know some of you might be rusty with logs, so there is a more brute force way to do this, is that you just remember that to solve an exponential equation like this, where you have some number equals a base to a power, the trick you do is you try to write this number as the same base to some power. And so I just played around with 4. I'm like, 4 squared, no, that's not going to work. 4 to the 3rd, not going to work. I kept going on and on up with that. And then I found out that 4 to the 6th is 4,096. So that lets me write 4 to the 6 equals 4 to the n minus 1. Once you've equated your bases, you get rid of them, and I get 6 equals n minus 1. And that also gives me n equals 7. Logs are definitely a better way to go, but you're not limited by having to use logs. I also have videos that explain how to do logs, so if you need that, just shoot me a note, give me a comment, and I'll give you a link. One last example. So this is a fairly common situation that you actually might bump into in life, is things depreciate. So when you buy an asset like a car or a TV or a computer, that loses value over time. Houses are different. Houses appreciate, but we're not doing houses right now. I might give you a quiz question with a house though, and that you would need to be able to solve. So check this out. A car depreciates by 19% each year. This is not unrealistic, which is why cars are not good investments. So, and you're going to find out just how bad of an investment they are. So it depreciates by 19% every year. If it costs $33,560 new, how much is it worth after 4 years of ownership? We're going to find that out in just a sec. Now, the correct mathematical way to solve this is by using our formula for geometric sequences. And this is indeed a geometric sequence. So check this out. I'm going to ask you first, in this situation, what is our n going to be? And then what is our r going to be? It's all figure outable from what's here. So pause the video, think real hard about that. All right, let's see how you did. Now, the thing here that's a little tricky is that n is actually 5. And the way you have to figure that out is after 4 years, we are at our 5th term, which means n is 5. Because at the start, which is actually 0 years, our value is this. So at the end of 1 year, we're at our 2nd term, our 2nd value. So at the end of 4 years, our n is actually 5. Okay, so there's our n. Now our r is also a little tricky. Remember, 100% is 1. Now, at the end of a first year, the car is worth 81% of what it was worth at the beginning because we're going to subtract 19% from its value. So what we do to get the R is we subtract 0.19 from 1 to get 0.81. So at the end of 1 year, the car is worth 0.81 times its value. And at the end of 2 years, it's 0.81 times the value after 1 year, and so on. So this is a common mistake that people make. They'll just grab this number and put it in for R. But remember, when you're depreciating, you have to subtract that number from 1 to get your R. Okay, now pause the video, do your plug-in step, and find the value after 4 years. All right, so here's my plug-in step. U5, which is our 5th term, which is the value after 4 years have elapsed. We take the first value, the initial new price of the car, we multiply it by R, which is our 0.81, to the 5 minus 1. That gives us our value of $14,446.48. Now, check this out. In 4 years' time, our car has gone down to less than half of its original value. So, obviously, not a good investment. However, the thing is that we got a car, and we used a car, and that's what we're paying for, is to have a car in our lives to do all the things that it lets us do. So it's not like it's a bad thing, it's just that it's not an investment. Now that you've watched the video, take a moment to jot down extra notes or jot down some questions for our next class. You can also re-watch portions of the video that you didn't get the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.